Okay, another interesting example is regarding elevators. It's not very difficult, but just you have to watch out for your signs and identifying which forces are causing what. Here's a typical question involving an elevator. Suppose you had a person standing in an elevator. And I'm going to make this person standing on a scale. So right here, here's a scale that can read their weight. Essentially, so if I have this person here standing, okay, and right now, if the elevator, of course, is not accelerating, the scale will read their weight. The reason being, okay, and I want to identify this. The reason being is that the person, okay, will have a mass, and their mass will have a force of gravity, which will be equal to mg. So they'll have a force of gravity mg. Now obviously they're not falling through the scale, they're not accelerating, and so the scale must be pushing up on them, and it's pushing up with the force normal. Okay. Turns out that the force normal and the force of gravity in this situation are equal if the elevator is not accelerating or not moving. The force normal is equal to force of gravity in this case. Turns out that the force normal will be what the scale reads. The reason being is because of Newton's third law, that if the scale is pushing up with the force normal, that means you must be pushing down with an equal and opposite force of that force normal. Okay? So if the scale pushes you, you push the scale with that same amount, and that's what the scale will read. So in other words, the scale will always read what the force normal says, not necessarily what the force of gravity is. This may not seem completely obvious at this point, but I'll show you with an example here. Okay? Now, I'm going to do that same picture, but in this case here, I'm going to make the person standing in an elevator. So here's the elevator, and there's a scale, and they're standing on the scale. Now, in this case here, I'm going to make the acceleration going up. Okay, so there's an acceleration going up into the air. It turns out that the force of gravity will be, of course, pulling down, and the force normal will be pushing up. But if this person's accelerating up, it must mean that they're having an overall net force up. In other words, the net force is also up, okay, in the same direction as the acceleration. Well, the net force is equal to ma, but it's also equal to the sum of the forces. And the sum of the forces here would be equal to, well, I'm going to make up positive because everything's moving. Okay, I'm going to make up positive. And so the force normal minus my force of gravity would equal ma. This is your net force right here. Force normal minus my force of gravity would equal ma. Well, what does the scale read? Well, the scale is going to read this, the force normal. And so my force normal is going to be equal to ma plus fg. And sometimes we can even simplify this and just call it ma plus mg. Okay? Or even furthermore, say ma plus g. And notice here that this will be what the scale reads right here. The normal force will equal to acceleration of the elevator plus the acceleration due to gravity, which we have as 10 meters per second squared. This is a scenario when the elevator accelerates up. Well, what if we changed it, okay, and the whole thing, and I'll just box this off here, what if we changed it and we made the elevator accelerate instead down? What would change? Okay, well, the difference here would be I'm going to make down positive and up negative, and the reason being is because I want it in the same direction as my acceleration. So doing this will result in force of gravity minus Fn will equal ma. Fn is still pointing up, which is now negative, and Fg is positive. So that's the difference. Moving this around here, you're going to get here that Fn will be equal to Fg minus ma, or m times g minus a. Notice the difference here when it's accelerating up and when it's accelerating down. This isn't something I would memorize, but it's something that is very useful in terms of solving problems like this.